Hello. Today we are going to talk something which is very basic and simple, however very useful. Something what is hard to come by yourself. But first, who am I? I'm Kristo. I'm working in Wise. Have been working in Wise for about 9 years, and I'm as a principal engineer right now. And in Wise, I've been doing so many different things, building a product, sometimes optimizing hardware rate controllers, so databases will perform better, and such. But essentially, I would describe myself as a Java programming expert and also database expert. Those are my main areas over time. And what I'm going to talk about is one interesting story or a case study with Wise, and something which can happen to every startup, and if they don't handle it well, they will die. So there is this kind of point in time in every startup. And at the start of 2018, Wise started to have a lot of outages, and also our availability of systems were going down. And this was a time when we got really huge traction and growth on volumes, but also a time when we started to build more and more microservices, moving out from our monolith. And something essentially had to be changed. We saw that if we continue with that, we will get more and more outages, and customers will move away. And we are going to talk about availability today. This can be defined by different means. What we are looking for today is something what is also in Google SRE book. So technical availability is basically about successful number of requests compared to all requests. So if you have about 80 successful requests and you did 100 requests, then your availability is only 80%. And here is question for you. That typically if you have a logic, let's say an API endpoint, for example, which needs to answer, needs to do something, it typically depends on other components, other services, but also database is a typical example. And if users technical availability is 99.9%, classical 3 nines, and database availability is also same, what will be is availability of transfers API endpoint? Just think about it a little bit. And actually numbers are quite realistic as well. Today we are aiming at 99.95% of availability, and as you probably know, it gets exponentially harder and harder to implement or achieve higher availability. So what is it? And it's probability, theory calculations what we can use here. So it's a multiplication of two availabilities, and we get only 99.8% availability. But it's not real world scenario. In real world you could have 10 different services. A request goes over through some different microservices chain, a service call chain. And if any of those components, you cannot build those components with 100% availability. And as you can see, if you have already 10 services, we get only 98% availability. 98% availability is something what you can't do business anymore. Two customers from 100 will get something erroneous. So what can we do about it? That was like our question as well. As I mentioned, like it's not feasible to say. However, like in real world, a lot of people say like naively, like, or leads are saying that, guys, let's build like 100% available, perfect, like bug-free components, but it cannot be done. And why? Because I mean, depends on complexity as well. If you have like very simple components doing something very simple and straightforward, like only one thing, you could have like very high availability. But anything like typical business logic services, which have, let's say, 50 different endpoints and different background processing and using like messaging systems and databases and other components over network. So in real world, you have like bugs, right? You have network blips, and you have like disk blips, like RAID array storages will have pauses when a disk is broken to synchronize it like a second. You have like phenomenon like tail latencies everywhere, so you cannot do it. But what if we could just like retry? And you could argue that not every error is like retryable. If your data center has lost power, then retrying it immediately won't bring us any like benefit. But you will be surprised like how many errors actually are retryable in real world. The same blips what I mentioned, optimistic lock failures, for example, using Hibernate or your own like optimistic locking implementation, database deadlocks, lock timeouts. Sometimes, not sometimes, but almost always a service is actually served by multiple shoulders or nodes or pods, whatever we call those. And often there is a problem with only one pod. And there is a high chance that the retry will actually go against the other pod of that service and may produce actually, not may, but highly likely in practice produces a successful result when the previous try against other pod was giving error. So retries could be, I mean, if you look at mathematically as well, and if you do 3 retries on that transfers, we could see that if all errors are retryable, they are not, but let's assume they are, we get like 5 nines. So wouldn't be like it interesting or useful. We had like suboptimal components with low availability, but now if we take it like a whole wise, we got like 9 5s availability with retries. And in practice it actually works. Not as perfectly as this, like sometimes you have errors, situations which cannot be retried, but it does increase availability and a lot. So both like theoretically, as we see here from the formula, but also in practice. Something what every engineer should know about why components cannot be built as bulletproof is distributed computing fallacies. Like everyone can later maybe search for those and understand what those fallacies are. Like one is very funny, like there is one admin kind of, but you'll see if you search. So retries are extremely useful. One point I would like to make like here without going out of focus like later is that you can retry also actions which are mutating something, changing like database. Even those can be retried. And in Wise, one of my colleague Peter Turovsky has built open source idempotency for J library for Java-like services. So you can take a look and understand how it can be achieved. So in 2018 in Wise, we went over the same kind of like logical analysis what I did just right now. So retries are useful. Let's just start using retries. And what we did, we put like retries between every component, or every service hop basically had a retry around it. And what can go wrong? I can say it ended up like really badly. And essentially, this can be explained with one like simple example. So let's say we have this kind of service call chain. Let's assume like it's a one-to-one like call as well, and this rate service does a one database call. But you know, like databases are not working like perfectly. Sometimes they can generate a really, out of the blue, they can generate a really bad explain plan or query execution plan for a query. Or you can release a bug like a bad query. And essentially like one query started to work very slowly. And now if we wouldn't have like retries, then we would have had only one like query in a database, but we ended up having one like request coming in, transfers API call, and we had 125 so slow queries running in database, taking a database down and having an outage. And just an example, but it was actually a pattern like happening like everywhere. And what went wrong is that we retried on timeouts as well. So this query was running long, right? But every hop had a timeout, let's say 15 seconds. Query was running 5 minutes. After 15 seconds, a component checks that, okay, I didn't get an answer in 50 seconds. So it's an error. I'm going to retry it. And now another query was running in the database. Again, like retry. But those retries didn't happen only in that estimator and rate chain at the end, but every level was doing the retries. So we got like 5 times 5 times 5 retries happening in that end like component. And now we panicked. We started to take over the out all the retries from code, like sending Slack message and don't do retries, it's really bad. But we saw like retries are actually useful, right? So what could we do about that like here? Actually, we defined a name as well. I don't know if it's something what other companies are using, but we started to call those retry bombs, like retries bombing resources underneath. I mean, you can also like argue that, you know, like, I don't know if you are like Java engineers, there is a retry template what is used in Spring like world. But if you implement like a retry as some kind of like while loop, right, then you could argue that what if we had like if statement, that if it's a timeout, then let's not like retry. Yeah, you could do it like at the end of the call chain. But typically what happens is that if upstream service, upstream means at the end of the request, downstream means like the beginning of the request. At least we use this kind of like terminology. So if it's happening in upstream, yes, you can understand it quickly, you got like a timeout, but this upstream is providing usually 500 to the service, 500 like HTTP response code to the service above in the downstream side of the service side, and it cannot distinguish like was it actually a timeout or was it like a simple error. So distinguishing like timeouts in the all service calls is not like so straightforward. So how do we avoid retry bombs? And how do we avoid like useless work? Useless work is something what I define as a work where a result of that work is not needed anymore. So in this previous case, as we had this database query still running in a database, so the services had already timed out with errors, right? And when this query finishes on the database side, no one is needing that result anymore. So the question is like, why do we have like this query like wasting money for us, or even like overloading databases? We don't have to have like so-called like useless work. And we started to think as well, like how do we avoid those retry bombs and useless work in general. Useless work and avoiding useless work has applications like outside of retries as well. So it's more like generic issue on services. So what we came out, and it's not probably something which is unique in Wise, and the concept itself has been talked in some like articles as well, but it's not like very widely used and known as well. So we started to use end-to-end deadlines, which basically can be explained that when a call comes in API call comes into Wise from Ingress, then we are setting like the deadline until the API call has to be finished, has to like finish and return response. Deadline, like technically, is a point in time, like a timestamp, epoch in time. But when I'm talking it as a like interval. So if I'm saying like that deadline is 15 seconds, then it actually means deadline is now plus now plus 15 seconds. And now what we are doing is we are propagating this deadline information through the service call chain. So every service in that call chain, including service which does database queries, knows what the deadline is. And we can now utilize this as following, that if a service gets a call and it sees that the deadline is already exceeded, it will immediately give an error. It doesn't try to do any work like database queries or anything like that. But even more interestingly is that when we are doing now database query, then we can put database timeouts based on that deadline as well. We can put like query timeout, idle in transaction timeout, lock timeouts, different timeouts. So when this deadline is exceeded past, after that, like everything what we are doing is useless work because no one is needing that result anymore. Client, mobile application or web application already presented a timeout error to the customer. So there's nothing to do with that, no need for that result. And now now if we think about the same like retry bombs, how it helps against that. If we got like a timeout, right? So we had this issue where timeouts were creating request amplifications. But now if we get the timeout with retry, the next service which is getting the retry call sees that the deadline is already exceeded and will return like immediately error. So we don't have any database calls or any other like service calls or any other like resource calls being done after that. And now we can put like all the retries back to wherever place you need, how many times you need. So we don't care like anymore. So the architecture of services comes simple, right? Put like retries everywhere. And just like maybe not so out of the context, like not out of the context, but maybe a comment as well, that we even do most retries in Wise on service mesh level, like delegating it out to service mesh from services. But in order to implement deadlines in your organization, it's not like so like straightforward and it's not like so easy as well, especially if you already have like a lot of microservices and a lot of components. You have proxies and service meshes and different maybe technology stacks already like Java and Node.js. Then it takes time to implement it. I'll come back to this point later, like one more as well, why it's like cannot be just like configured or something like that. But let me show like how in Wise what we had to do. So we had like Java services, Node.js services, Nginx, Ingress proxies, Apache Ingress proxy. and databases mostly, but also like async workflow around messaging systems, asynchronous jobs and tasks as well. So what we, but the implementation, it's very simple actually. It just takes like time. So what we did was first we defined clear HTTP header, which allows us to propagate the deadline. Then we created a service ingression library, which is just like an interceptor or filter, or I'm not like very aware like of the audience, like what kind of technologies you use. But so I'm trying to generalize a little bit, but essentially some kind of like service ingress filter, which takes this deadline and puts it into request context. This request context can be, for example, when we are talking about Java, can be a thread local, for example, or in Node.js, like some kind of like context in for that like request. And why we are doing it is that, you know, like we need to propagate this deadline. So now for this request, every service call which goes out from that service needs to get the same deadline what we saved in the request context. And we need some kind of like, in order not to manually like propagate the deadline for every single service call implementation or code, we should have like some kind of library as well, which is able to automatically intercept all outgoing requests from the service and add this header like to those requests as well. And also like what we built was database wrapper library, sorry, which was again like intercepting every database query, checked like what is the deadline in the execution context, and tweaked different like timeouts on database queries. So it's kind of database wrapper library. And for more like advanced engineers who have like dealt with those deadlines issue before, sort of, you know, like it's not again like so simple in real world where time in different ports or servers can be different, right? So there is a clock skew kind of phenomenon where if like one service sets like a deadline to something in the future, especially when it's like very near, let's say in 100 milliseconds, then when this call actually ends up in the next service, it can see that the deadline is passed, but not because 100 milliseconds was passed, but because its clock is wrong. So clock skew. And there's basically two ways to propagate deadline. One is to propagate as a timestamp, another is to propagate as an interval. And both have like pros and cons, so it's a trade-off. Our method was to propagate timestamp, which has a benefit of being more accurate. And the downside is that it can have like a clock skew at the end of call chain, calling deadlines as passed like too early. But we actually implemented a small mechanism to avoid that as well. So it's not like a huge trade-off for us. If you check, for example, gRPC code, which is a few libraries, open source libraries, which has deadlines as a first-class citizen, then you see that Google chose interval carryover like mechanism. And as I briefly mentioned before as well, deadline is not useful only for synchronous like service call chains. It can be used for asynchronous works as well. Let's say if you have a background job or task running, you could set like a deadline to it as well, let's say 1 minute, and now you protect like all resources what this job is using as well for retries or for other like reasons. But when we are talking about like deadlines, it may maybe devalue timeouts. Timeouts are still useful, and I'm trying to describe how timeouts and deadlines are interconnected. And as you know, like if you build robust system, the easiest thing and the first thing you should think of is to have timeouts everywhere. Every time you do a network call, timeout. Every time you do like a database query, put a timeout like there. It can avoid hangs, resource hogging because of those hangs, like thread starvation, for example, is a typical example like here, but it can also protect like resources. Same case with database queries. If you set a timeout of 1 second for a primary key like query, then or other simple query which you assume will be simple and fast, you can avoid surprises and avoid database getting like overloaded. And something what people like ask, of course, or go their mind is that again, like they are fixated on building bulletproof like systems with 100% availability. And now they ask that, okay, but if I start putting like timeouts somewhere, then those timeouts can actually happen. They will trigger like errors, and now I will have like errors in my system. So I don't put like timeouts somewhere. So this is kind of like logical thinking goes through like engineer's mind. But the order of if you compare like timeouts versus not timeouts, then in practice you see that the availability is multiple orders of magnitude better with timeouts than without timeouts. If you don't have timeouts, your database gets overloaded, it's down for two hours, versus you get like some like timeout blips occasionally. This is basically fault tolerance, that if you have something like creating errors or other problems, you don't want that part affecting any other part of your system. That's like fault tolerance. And fault tolerance is not like building faultless services or something utopic. So if you take something from this talks and like only one thing, like then I would actually emphasize usefulness of timeouts. But how they can work together with deadlines? They actually go like hand in hand. And even when we are setting end-to-end deadline at the beginning of request in the ingress like proxy, then it doesn't mean that you can have like a smaller timeouts for every hop. So if you have like again like database examples, that if you had like end-to-end deadline 15 seconds, but you are doing a simple like database query which you know has to finish in 1 second, it typically takes like 2 milliseconds, for example. You actually want for resource protection to have 1 second timeout for that query, not 15 seconds from the deadline, right? And here is like same example what I just described as well. That you still want to protect your database, have small timeouts, but it doesn't apply only for databases. For example, if you add this rate service, an estimator service and rate service in that call chain, and you know like that the rate will always answer in something like 100 like millisecond, you again want like for resource protection to have small timeouts there as well, maybe 200 or 300 or something like what we use is like 99th percentile of historical data, like peaks multiplied by 2 or whatever like formula you use, but you want to have it much lower than 15 seconds. And in practice, like it works like here on this graph. So as you can see, like we are setting end-to-end deadline, but we are also like configuring timeout for every hop And now when a request comes to the next part or component, then now it's very important to understand that the end-to-end deadline can change. So here, like when transfer is calling codes, and this link had configured 5-second timeout, and even when the deadline is 15 seconds, like the end-to-end deadline, then everything what is happening from transfer side more than 5 seconds becomes useless work, because after 5 seconds the transfer service will give an error, like timeout error. So from that on, we actually want this end-to-end deadline to be 5 seconds. So everything what is happening like behind that transfers now get like 5-second deadline. And when we have a database at the end, of course, we don't want to propagate the deadline anymore. Then we are just calculating the query timeout based on if the configured timeout is smaller or deadline is smaller. We are always picking like the smallest amount of time. So basically, it's jumps like deadline timeout kind of way. And end-to-end deadlines is only one like mechanism to achieve like fault tolerance. And if you are like a startup engineer and you don't want your startup to die at this point when it gets like a huge amount of new users and your systems are built like naively, you need to is the wrong word, but should start familiarizing yourself with all the fault tolerance concepts, where timeouts and deadlines as well are just like one component. And that was like not like question, but my rhetorical question, like why it's hard to implement deadlines. Why cannot we just, let's say, in Java ecosystem, like take in like some open source Spring library or open source like database wrapper library and puts like Nginx proxy somewhere and it will magically like support deadlines. The problem what I see is that open source world doesn't reach like that kind of scale what companies like Wise have. And before you don't reach that scale, those problems are not known to you. You only discover those problems at that scale. And this is my theory. I don't know if it is like so or not, but I would assume that open source world engineers building open source libraries and tools are not aware of this problem. And if you are not like aware, you cannot like build it as well. And there is no like understanding it in my mind, and there is also no like standardization. And that's why like unfortunately you will need to build like this stack yourself. But it's not super hard as well. Like you put like maybe 2-3 like good engineers on the problem, and they will, and especially if you have like one technology stack as well, it will help like a lot. And it doesn't take like too much time as well to build this propagation and polish it. Wise has a lot of fault tolerance libraries, but we haven't done so or published those or made those like open source libraries because they are quite opinionated, very like Wise specifics. Why they are so because it allows us to keep the feature set like very small and have like velocity of changes very high on that libraries. If you would open source it and not just making like library public, right, but more like supporting and covering like all different feature sets and use cases what all the world will need, it will need like considerable like investment. So that is like why we haven't done it. But here in this slide you can see like most of the fault tolerance mechanism as well what you should be aware of, like deadlines, criticalities, overload protection, idempotency idempotency and retriable, even on mutating unit of works, graceful shutdown, self-warm up. Those are like topics like when in WISE we get like interviews as well from very like strong candidates, and usually one of like 100 engineers have even heard like that term. So that is not like easy to discover for yourself, but if you know like those terms, I strongly like recommend to do more like research on those. So in a summary, before questions, retries are useful, but only if you do it like right way, and deadlines is one of those right way to make them like easy. And it works for us. So those outages what we had in 2018, where WISE was down for let's say eight hours because database was overloaded, and we tried to restart it, so it maybe bring up the legs again, and so we're basically left into that year. And now most of the incidents which we have are only happening in specific components. They are not like affecting all other components, even in a service. So that's it basically. So thanks for Lauri Võsandi to invite me here to share our like experiences from WISE as well, and I would gladly answer any questions you have.
So you mentioned you have the ingress controllers also implementing timeouts and stuff. So you have patched it yourself, or is Nginx ingress already supports it out of the box?
Everything what we needed we were able to do with Lua, so we didn't like need to build any patches or plugins. Okay. It's quite simple as well in Nginx. We have like a configuration files which lists all the different endpoints. Engineers can mark what is the deadline for those endpoints. This Lua script will basically find the right entry in that map and then puts that deadline header, basically same header, and now it gets propagated through the service mesh to the first service behind that ingress like proxy. That has already our like Java or Node.js libraries, which does work what I described like before. Okay, cool. We didn't have to do like anything what I don't know, which would require more complex things or complex like learnings, like writing Apache plugin, for example. We didn't need any of that.
Thank you.
Yep.
As understood, you have some global deadline. Do you have an exemption from that? Like, let's say 15 seconds, but for some specific requests, you can add 5 more.
Yes. So I don't know if you have like those anymore, but sometimes there was like a case where synchronous request was doing something where the work was still needed. Let's say ops was changing something in payment, which took a lot of time, but even when they got like error in a back office like tool, they still wanted this change to be done. And sometimes it was many cases it was more like a batch kind of like operations where they changed let's say 10,000 of payments at the one time, and when there was some kind of like latency or more like the issue was that the implementation was not like supporting like large batches. So we applied like deadlines. Now they started to have like transaction like rollbacks because deadlines and timeouts were exceeding, and they were not like able to quickly rewrite the logic. So our libraries actually allowed as exception in the service side like to extend the deadline. But it was like temporary, so they extended the deadline, it worked, but on the side like they put it to sprint or next sprints or plans that we need to rework this logic. And what they did in this case was to rewrite it to asynchronous like kind of workflow.
whole system where you got the control from end to end. Like you can start the control that okay, here comes this one request from the user, and you can apply the whole chain through it. But let us say that you are making a component just as a part of the whole, and you are in the middle of it. Let's say you are getting those 25 requests, and you already know that okay, this is a problem here. There was this one valid request which has been retried 5 times, and now you are responsible for the one component. Is there any kind of internal throttling mechanism that still would help? Does something come to your mind?
We have. If I understand like the question correctly, then we have another like fault tolerance mechanism implemented, which is overload protection, and also like other like really useful like pattern to avoid any kind of overloads or hangs in services is to avoid like any queues or any like high concurrency or queues. If your concurrency like goes too high, we just give like error to that next like request, which increases the concurrency more. And technically you can also implement this kind of, if you do it like correctly, and you will return like a specific error code as well, let's say 429, which is standard like HTTP header. Then on client side, you could actually implement something like TCP, like ingress ingestion like control. So that you will make the client like concurrency, or makes the client like to call like less frequently, for example, to throttle itself, for example. So this is something we also have another like mechanism. It goes like it's separate from deadlines, but you can do it like that way. It's something what you can also, I recommend to read this Google like SRE books. Check for a section where it talks about criticalities. We use, with the overload protection, we use everywhere 4 different criticalities by the same book, like sheddable, plus, critical, and critical plus. And if any service needs to make a decision that it cannot like handle more and it has to discard something, then it can, and those criticalities will get propagated as well to all like service chain. Everyone knows what criticality is end to end. And now like every component can make like decisions that, okay, if my concurrency goes too high, I'm going to start like first rejecting like schedule, some kind of patch or migration like request. But if it's a critical plus, let's say you are doing using a Wise card in a grocery, it's a critical plus, and this one will be discarded as a last resort only. So yeah, Google SRE book again, like has a good like knowledge or ideas.
Thinking like, what would you recommend how to develop this kind of fault tolerance directed thinking and practices, unless you're working in a big company already?
The problem what I have seen like in my career is that the main problem what you will have is you will find it very hard to reason it to people who haven't had the issues what fault tolerance is solving. So if you don't have like those outages in companies, then your leads or your decision makers may not find any value of that. So before the first like outage happens, then everyone is like, why don't we have fault tolerance system built? In Wise, like we didn't have very hierarchical like system or organization, and we didn't have like anyone making like technical decisions for ourselves. But it was similar like psychological effect for us as well. So we always had like something. There's always something to do in Wise, like product needs like work, and you have to prioritize like between product work and technical work. And to be honest, like we in our Wise like engineering community started to build like fault tolerance only when we started to have already very serious like issues. But I don't know, like you could like reason it that okay, Wise almost like died in 2018. That if we don't want to die, then we should build at least something. But this something what I mentioned as well, we figured out like quite nice way to implement it, or how we built this system is that we didn't assume that when we have all those libraries present, that every service owner invites like different teams own different services. If you want something to be done for those services, you have to ask them to do. But we immediately understood that it cannot happen that we will send kind of like company-wide email and ask everyone to adopt this library. We assumed that it's going to happen in 2 or 3 years like window. So the system was actually built in a way that if not all services are having the libraries on, it will immediately start like providing value. Maybe just between 2 hops. Maybe now like when you add more service, maybe just between like 3 hops. And so on. So and even now like we don't have it on every like service, I can honestly say, because there was again like from my point of view, there is like another like psychological block. We got like our availability up because of those systems, and now the priority went down for service owners which are missing the libraries. They see that okay, availability is good enough, so we will do something else, which is fine. I mean, I cannot, or in our case like SRE team, in my case like SRE team cannot like possibly understand like what priorities every team has. So we provide like solutions. If you have this problem, we have a solution ready, but we don't like force you to set it.
Could you like flush it out preemptively somehow with stress testing or something?
Could, yeah. You could like, you could have to demonstrate the priority basically to teams and leads, and stress test would be like one way to do it, I would imagine.
So what is your current availability? After the comma?
Something like 99.97 like week to week. But we also have incidents which bring it like down on some, but those are quite rare like weeks, and yeah, something like that. It's hard to say because you know like how to measure like the whole availability. So we have a couple of like critical flows where we are running like a test suite constantly against it, and it measures like that availability, like how many like succeeds and fail, and that gives availability what I was mentioning. This basically, test suite is actually outside of our perimeter, so we can also include like all the network stack and wide area network and all that. But we also looking every service is measuring availability from their side as well. And currently we are generating like weekly reports, like a large picture, like what kind of availability every service has. And as I mentioned here as well, we are aiming to 99.95. So then the graph is like green for that service. And typically like, I don't know, just like from my eye, like something 95% of services like are green like every week.
But is it different by region, let's say?
We have one region in that sense, that all the servers are in one place.
And easy to manage, easy to measure.
Yeah, and keep latencies low. That is also something what we have implemented by Google SRE book. Like one of those books again is monitoring or observing like SLAs, but also like I think it's called like not burn budgets, but error budgets basically. So we have actually alerts coming in for service owners if they are burning they have like incident, like really high like error rate, and they are burning their, for example, like weekly error budget. So I mean, we're not using it strictly, but the idea is that you want,
Measuring the money.
yeah, not measuring it money like directly by metrics, but in what you want to have is that if your service is like broken, then at one point you want to fix it, right? And you want teams to prioritize as well, like fixing, not like continuing, letting it like degrade like more. So if a service has enough like errors in some like interval, is it like week or months, and it has like so many errors that you see that you don't like reach this 99.95 anymore, then this alert will tell like teams that, come on guys, you now have to prioritize like fixes, like maybe those are technical fixes, and stop your product work because your availability is going like down and it's not like acceptable by WISE like standards. So that's basically about like error budget.
I think there's no more questions on YouTube.
Cool.
Okay, I guess we can then wrap it up.
Thank you.
Thanks.